have Kerry Osborne in Poland, dude. That's amazing. Welcome. Thank you for being here.
Cheers.
Hope you're enjoying your beer.
So far, so good. It's a breakfast beer.
It's a breakfast beer, yes. Mm-hmm. Breakfast beer is the best always.
Mm-hmm.
Is it your first time in Poland?
It is.
We are double honored. First time in Poland
Yep.
and at POUG.
Yep.
You would have, I talked with Kelly previously. You would have a panel session at the end.
Yep.
And I asked her some questions about it, and now we will check.
See if we have the same answers.
Everyone will know.
Okay.
I know already that the rule for being in a panel session is to have a ponytail.
Yes.
So, okay, that's confirmed.
That's confirmed, yep.
To us, you have big experience right now with not only relational databases as previously, but also with this new, modern, fancy kind of NoSQL stuff. How is the transition? What are you doing right now with it?
Yeah.
What's going on in the world?
Yeah, not so much the NoSQL stuff, but certainly alternative architecture. So Hadoop in particular is something that we've gotten pretty interested in. And the main reason is several years ago, probably 7 or 8 years ago, I was working on a project. We were doing a performance tuning engagement for a chip manufacturer down in Austin, and they had a 100 terabyte database.
100 terabyte.
This was like 8 years ago, 7, 8 years ago. So that was a very, very large database at that point, Oracle database. And as we were, we'd done some analysis work and we're presenting the results in a big conference room with, 20, 30 people. And the main guy in the middle of the presentation, he gets up and says, he excuses himself, says, "I got to leave." And I'm like, "Wait a minute, we're just getting to the good part." And he's like, "I appreciate all the work you guys are doing, but here's the deal. This database, it was data coming off their manufacturing line. So it was basically IoT sort of data, industrial strength IoT. And he said, basically what's going on here is this is 7 days worth of history we have on this database, and it's 100 terabytes. And he's like, you could make this thing run 10 times as fast. We need a year's worth of data on this thing, and we're just not going to be able to do it, the way we've done it in the past. So we have to do something else. And I've got this POC, test thing going with Hadoop, that I'm working on in another room, and so I got to go work on that. So that was the point where I really started to think seriously about this alternative distributed software-defined sort of architecture. And from that point forward, we've had lots of opportunities to work on that, and so that's how we got interested in it.
You can hear some voices that this new stuff is here to replace the old relational database architecture. Is it true? Should we make a transition? Should we start to think as a relational database as an old technology? Or are they here just to, provide a different solution for different kind of needs?
Yeah, that's a really good question. I don't think SQL's going anywhere. I think SQL is going to be the language. There's so many people that know it, and it's so good at what it does. I think that is going to continue to be one of the main ways that we develop systems. I think I was on a panel a few years ago at one of the E4 conferences with Alex Gorbachev and a couple other guys, where we had we had a group that were arguing relational database for a data warehouse versus Hadoop for a data warehouse. I don't know if you were there and saw that, but anyway, on that at that point, I was sitting on the relational database side, and I was arguing Exadata could do, pretty much everything I wanted to do. Today, I probably wouldn't be on the same side of the fence if I was writing a data warehouse, a greenfield from scratch. I might choose Hadoop as my platform, still with the SQL language, with some native SQL language on it. But I don't think the relational databases are going anywhere. Certainly, Oracle, is the king of the world in terms of complexity of SQL processing. They've got a 30-plus year head start on these new engines that are sitting natively on these distributed platforms. So obviously they're going to they're going to be pretty far ahead. In terms of consistency and high volume transaction processing, they're just way, way better at this point. Ingestion rate, if we're not too worried about consistency, we can do all kinds of things. But there's just nothing to compete with it for things like banking and that sort of thing, where it's really important that the transactions be consistent.
It's not like new developers should forget about relational and go pure software-defined stuff and so on. It's
not at all.
It's here to work together in a big complex system.
Yeah, just like with most technologies, there's not like something is invented and all of a sudden everything goes away in the past, right? We still have mainframes working, right?
Yeah.
Right. And that technology was pretty much outdated 30 years ago. But that, once you've spent, many man years building a system, taking that system and trying to move it to a new platform is very, very expensive and very, very risky. And the risk probably outweighs everything else. We worked with a big healthcare provider in the United States several years ago now, and they had a Teradata system actually, and we were, as part of a POC on Exadata, we were trying to see whether we could do it better, and we actually showed them, I forget what the numbers were, 1,500 times improvement
1,500
on average. So we took every SQL statement running through this system for an hour. We picked the busiest hour.
Yeah.
Teradata is very well instrumented, kind of like Oracle. Took the busiest hour they had, took all those SQL statements, ran them on an Exadata, and the average was 1,500 times faster. And this was on a fairly large cluster, 6-node cluster, and we were planning on scaling it to show them we could scale it, but instead we cut it down to a very small system to see how small we could go. And we cut it down to like a quarter rack, basically, and it was still over 1,000 times faster. And now here's the part about the story, and the reason I tell you is that the company looked at the system. They were spending tens of millions of dollars on this Teradata. The numbers were something like $30 million a year in support. And so this quarter rack could have been bought for and implemented for, maybe $1 million, and the annual cost would have been, less than that, right? They couldn't justify the project. They were too afraid from a risk standpoint and a cost of conversion of the code to actually implement the project. Now, 4 years later, they finally did it, but it was very difficult for them to justify it. And that's the problem with the traditional stuff that's been built for a long time. So that stuff's not going away. New stuff will be built on these new technologies, and there will also be some sort of merging or hybrid type systems, which you're aware of. So.
Yeah, like Fluent is doing right now. So when I saw it for the first time, when Talon was showing it, I think I saw it for the first time in Birmingham, offloading stuff directly from relational warehouse to the Hadoop. This was pretty amazing. Do you have a lot of customers wanting that in?
Yeah, it's pretty common to have discussions with customers and say, yeah, we want something exactly like that. And Gluent's not the only way to do it. Oracle has a product called Big Data SQL. And most of the vendors have some way to access data in a Hadoop cluster or some sort of distributed architecture like that. But I think what we're going to see is for a long time, maybe a decade, we'll see applications that are still running in their native SQL engines, but some of the back-end processing is going to be done on a distributed platform like that. Like the one I was telling you about, the chip manufacturer. If they could have loaded, a year's worth of data in a Hadoop cluster, but not have to change all the thousands of reports that they had running on that data warehouse, that would have been an awesome solution for them.
So actually, instead of switching the technology, we should just learn another stuff to understand one piece and another, and how to combine them together and how to work together. So we have more and more knowledge to get, right?
Yeah. It's okay. It won't be that difficult. You'll manage. But the main point is to when new technologies come out, the problem we have as technologists is we get all excited about it and we all run that way, right? And then we find out it's not perfect for everything, right? And then we all run that way. So the real challenge is to use the technologies for what they're good at. So Oracle's awesome at SQL processing. It's awesome at transactions. It's pretty effective at big data warehouses, but there are some data sets that we're getting now. It's manufacturing data that's coming off a lot of IoT stuff that's where the volumes just get out of hand. We're working with a big telco It's another 7-day story. They've got 7 days worth of data, and it's about 400 terabytes right now. So, and again, they want
Those are cool numbers.
right, and they don't want it 7 days. They want a year or multiple years worth of data. So it just we need a technology that can scale, and so having a back end like that, with some sort of connection to the power of the Oracle piece of it, long development cycle already, that's pretty cool.
Kerry, I can't wait to discussion panel actually.
Okay.
Really, thank you for being here.
Cheers.
Hope you're enjoying.
So far, so good, man. It's early in the morning. Not too early. It's lunchtime, so that's good.
Yeah, it's almost lunchtime. Thank you once again, and hope to see you here at POEG.
Yep.
Also next year.
Hopefully, I can make it next year.